This video is over topic 23, numbers 1 and 2, finding z-scores. So the name for how many standard deviations from the mean, essentially the position on that diagram where we have our mean and so the mean there, and we're making these different positions. So the mean, each of these positions is a number of standard, like 1 standard deviation from the mean, 2 standard deviation, 3, plus 1 if it's to the right, plus if it's to the right, minus if it's to the left. So if I want to just say which position is it at, and I want to say it's at +3, meaning it's the mean plus 3 standard deviations, I can just call that 3, and what the 3 is called the z-score for that data value. So z-score is how many standard deviations from the mean. Z-score is positive if the data value is above the mean, negative if the data value is below the mean. So practice number 1, if we have a mean IQ of 100, standard deviation of 15, then someone with an IQ of 85, I look at, all right, going from 100, did we have to add or subtract to get 85? To get from 100 to 85, you would subtract. What you're subtracting is 15, but we want to know how many times. We could write that algebraically as 100. Let's just say 100 plus 15x equals 85. So we would subtract and get minus 15. That's where the subtracting part comes in. I did a minus here, but it comes out there. And then divide to say how many times. So to get from 100 to 85, that's 15. So subtracting 15 one time. So subtract, or let's put it this way. 85 is 100 minus 115. So that is the mean minus 1 standard deviation. The minus 1 part is the z-score. So for a person with an IQ of 115, 115 is 100 plus 115. One occurrence of the 15, or let's say plus 15 one time. But the plus and the 1 give the z-score. So this is a z-score of 1. 100 plus 15 is 115. This is plus 1 standard deviation. 145, I mean, that 145 is 100 plus something, plus 15. How many times? It would be 3 times. So when you're asking what do I add or subtract to get from this number, the process to do that is you subtract. So you would subtract 145 minus 100. Here you might just look at it and say, oh, 45 got added on without thinking that you're taking 145 minus 100, but you're subtracting. And then when you ask 45 is how many times 15, that's 45 divided by 15. So So when you're asking how many times, you do division to answer that. So this would be plus 3 times, so this would be a z-score of 3. But this gives then the z-score formula is the data value minus the mean divided by the standard deviation. So either memorize this, or this will be on the formula sheet, but this, you still have to know that it means this. The x in both cases mean the data value. The x bar or the mu symbol would be the mean. The s or the sigma symbol are the standard deviation. So you need to know what each of the symbols mean if you're going by what's on the formula sheet. So going to number 2 here, just calculating some z-scores. Again, how that is on the formula sheet. You will see z equals x minus x bar over s equals x minus u over sigma. So how we use that, if I'm finding the z-score for a student who scored 26 on the ACT, the student who scored 26, that's x. That's my data value, which has a mean score of 21.2. So this is my mean, so x bar or mu, and standard deviation of 5.1. So that's my standard deviation. It's the s or sigma. So whichever formula I'm looking at or remembering, I'm going to take the data value minus the mean and divide by the standard deviation. Again, if you remember what you're doing, this is to answer how many standard deviations is this from the mean. It's above the mean, so I need to do the subtraction in a direction that's going to get me a positive number. If it's above the mean, 26 minus 21.2 is 4.8. What you want to be careful about is if I do this as 26 minus 21.2 divided by 5.1, it will not work. Just be cautious of that depending on your calculator. 4.8 divided by 5.1 is 0.94, and a bunch of stuff will round to 2 decimal places. Then find the z-score for a student who scored 1230 on the SAT. That's my x, which has a mean score of 1060. That's my mu mean. You can see kind of an M there. So that's probably the easier to remember to know that that's the mean. And a standard deviation of 195. So that's my S or sigma. So this is going to be 1230 minus 1060 divided by 195. So I go on my calculator, 1230 minus 1060. I hit equals on that. I don't need to write that down. You can if you want. 170 divided by 195. I didn't need to retype the 170. I just hit the divided by 195, and that comes out rounds to 0.87. So if we're looking on this standard curve, they're not on these whole number 0, 1, 2, whatever lines. We would be like here somewhere. And what was it? 0.94 was it? 0.94. And then a little bit below that, 0.87. But that's a pretty tall part of the graph versus if I was at like 2.974 and 2.87, that'd be a lot less significant of a difference. So how far apart they are is also affected, how much difference that makes is also affected by how close to the mean. But the ACT larger Z score, so higher above average.